The objective today is to be able to describe what the Intel manual says about basic program execution registers. And this is coming off of a pretty rough former video where I attempted to tell you about canonical addressing. And for this video and future Intel manual videos, I'm going to make this little promise to you that I'll try to just stick with the manual itself. And if I do go on field trips, it'll really just be for a picture. But I need to save all that researching and dissecting for, I guess, another video series. I just strictly want to read the manual, ask questions based on the manual, and do something that's really hard for a teacher to do, just assume you really are understanding a lot of the tougher words that we find in the manual. I have a tendency to try to Eli 5 every 5 minutes. So let's go ahead and get started here. We're on page 73, section 3.4. And Intel begins by saying the IA32 architecture provides 16 basic program execution registers for use in general system and application programming. These registers can be grouped as follows, and so I really just took that and wrote it up above. You got your general purpose registers. These 8 registers are available for storing operands and pointers. You have segment registers. I think part of my problem with the canonical addressing paragraphs right here is I didn't know a lot about segmentation and segmenting, so I'm going to just work on making a whole separate video for that concept. But we have these segment registers, and these hold up to 6 segment selectors. We have Eflags. This is a program status and control register. The Eflags register report on the status of the program being executed and allows limited application program level control of the processor. So these flags are for like the 0 bit or a sign bit to make numbers negative. You just have a variety of different flags. And for some reason, I really don't know why, they put E in front of a lot of things. So when you see an E in front of IP, that's just indicating that that's the register in a 32-bit system. Now R, as in RIP, is just an instruction pointer for a 64-bit system. But anyways, this instruction pointer contains a 32-bit pointer to the next instruction to be executed. So I have quite a few questions based on just the reading so far. First, how many registers are for basic execution? So up there, first, how many registers are for basic execution? So that was in the beginning. There are 16 of them. Next, what 4 categories can we place these registers in? So that's right there as well. You got your general purpose, segment, Eflags, and instruction pointer. What size is the instruction pointer? Well, that's easy, 32 bits. And the next question we have not answered yet, so let's go down there to get ready. It says the 32-bit general purpose registers are EAX, EBX, ECX, EDX, ESI, EDI, EBP, and ESP, extrasensory perception, I assume that stands for. Just kidding, but it is the name of another register, and all these registers provide for holding the following items. These registers are holding operands for logical and arithmetic operations. So logical is like an AND or an XOR. So that's the question right there. What is a logical operation? Those are kind of funky, and they're definitely like a programming specific thing. But everybody knows arithmetic operations, that is addition, subtraction, multiplication. So that's what these registers are doing. They're holding those operands. They're also holding operands for address calculations. And then it has memory pointers, which to me completely relates to this concept of having a register that is holding a number, which is actually an address. And if we're calling it a pointer, that value of the address is pointing to where the next instruction is. So although all of these registers are available for general storage of operands, results, and pointers, caution should be used when referencing the ESP register. The ESP register holds the stack pointer, and as a general rule should not be used for another purpose. And then I ask the question hackers or just general curious people ask, that is, what would happen if you do? Would that reveal some sort of hack or vulnerability in the system? So that's just a rhetorical question not to be answered. Unless you know the answer, then I would really like to know. But let's not forget about our questions over here. Our address calculations all about taking the segment register and adding it to an offset to determine the pointer. So this is a question I want to make sure is answered because of this right here. I just want to make sure I'm not like pointing you in the wrong direction there. Okay, so many instructions assign specific registers to hold operands. For example, string instructions use the contents of the ECX, ESI, and EDI registers as operands. All right. So which registers hold string instructions? And I assume they mean instructions like to concatenate a string, that is to put a string together. Maybe an instruction like print the string. Whatever it is, that's what these registers are for. Now, when using a segmented memory model, some instructions assume that pointers in certain registers are relative to specific segments. For instance, some instructions assume that the pointer in the EBX register points to a memory location in the DS segment. Okay, so some of these are like naturally connected, it sounds like. So I hope this question makes sense. Where does the EBX register usually point to? They say some instructions assume that a pointer in the EBX register points to a memory location in the DS segment. And since it said instructions assume, that's why I worded the question the way I did. And I just wanted to show you real quick these segment registers. I mean, they're pretty easy to remember. CS is for code, and D is for data, S is for stack. It's pretty straightforward. Now, looking at pictures like this is almost worthless to me. Unless I guess a person is just like a turbo visual learner, maybe this will really drive home the point that all these registers are 32 bits, while the segment registers are actually 16 bits. So okay, I could kind of buy in right there. And maybe they're just going in order from above, how they laid out these registers to us. But then at the bottom here you got your program status and control register, which looks like it's another name for Eflags. I wish I'd just choose one and stick with it maybe, because I read somewhere like PSCR. I kept reading that name of the register constantly. And it's just a single register with a bunch of flags, so every bit is a particular flag that has some sort of importance. And also, I mean, some of them are actually blank too, I believe. So not all 32 bits are used as a particular flag. So we're scrolling down into page 74 here. It says that the special uses of general purpose registers by instructions are just described in chapter 5. That's what somebody on YouTube asked me to get to. So believe me, I am working on it as fast as I can. But apparently we can also see chapter 3 and 4 to get a better idea of these general purpose instruction registers. However, in the meantime, here's a brief breakdown. EAX is what's called the accumulator. It is for operands and results data. I want you to really fixate on the fact that an accumulator is simply a place to store results. So that's such an important idea to me. I even made a question out of it. So what is stored in the accumulator? What's the name of the accumulator registered? And so that's EAX. I've seen hackers or people who call themselves hackers on like Reddit and Twitter use the name EAX in their name. So I think it's just one of these like very important registers. Now we have EBX, we talked about that before. It's a pointer to data in the data segment register. Moving on to ECX, this is a counter for string and loop operations. If we go up here, ECX, is that one of the things for strings? Yep, it's the first one right there, so this is all about string instructions. EDX is the next one, and that's an I/O pointer, and I didn't see EDX mentioned before. So just an interesting one that I do want to learn more about. So just a rhetorical question, like how does an I/O pointer work? Something for me to invest future time into. We have ECI, which says it's a pointer to data in the segment pointer to by the DS register. Is this me reading it incorrectly? Pointer to data in the segment pointed to by the DS register. Yeah, I was reading it wrong. That second time sounded better. And it has a semicolon. It says source pointer for string operations. So ESI, is that one of our three? Yep, it's the second one of our three. Next is the last of the three EDI. This is a pointer to data or destination in the segment pointed to by the ES register. Yeah, ES register. I don't remember an ES register, but semicolon destination pointer for string operations. So whatever it is, it's related to strings. Let's finish by talking about extrasensory perception. Just kidding, ESP. It is the stack pointer. Alright, we got EBP. This is a pointer to data on the stack. And I'm like, I thought that's what the stack pointer is doing, pointing to data, but no, that's the base pointer. So this is the top of the stack, this is the bottom of the stack. I don't know why they don't more clearly explain that right here. Well, it says, as shown in Figure 3-5, the lower 16 bits of the general purpose registers map directly to the register set found in the 8086 and Intel 286 processors. So remember, this 8086 is really old, 1978, and then just 1 year later the 8088 came out. Interesting history. I got videos on those. Not to mention there's actually even better videos out there on YouTube about the history of those two processors. But what's interesting is the lower 16 bits of the general purpose registers map directly to the register found in these chips, and they can be referenced with the names AX, BX, and so on. Each of the lower 2 bytes of the EAX, EBX, ECX, and EDX registers can be referenced by the names AH, BH, and so on. And those apparently are the high bytes, and then the low bytes is AL, BL, and so on. So interesting, if I want to get the value of this, I can reference that and get it. And it's all a part of this register. So AH for high and AL, L for low. My question to maybe help you remember this is, how do you access the lower 2 bytes of these general purpose registers? And I'm just talking about these 4. And let's end the video with a picture of that. Maybe you're sitting there thinking, what is the word reference mean? Well, when you're looking at the assembly code, even if you're typing it yourself, like, you can reference it, you can literally type that register into your code. So here we have CL and CH together, so we're going to compare those two. So what a great introduction to just the general basic program execution registers. In the next video, we'll go ahead and go over a general purpose registers in 64-bit mode, because all of this was simply 32-bit.